Welcome to this advanced architectural session. Today we will explore how to manage quotas, scaling, rate limits, and cost footprints for your model and agent workloads in Microsoft Foundry. Welcome to this advanced training on managing quotas, scaling, rate limits, and cost footprints for your model and agent workloads in Microsoft Azure. When building generative AI solutions, proper planning and preparation involve identifying the exact services you will use and creating an optimal, scalable working environment. The Microsoft Foundry Model Catalog serves as your central hub, offering over 1,900 models from various providers. However, choosing a model is not just about its cognitive capabilities. It is fundamentally about managing your operational cost footprint and ensuring scalable performance. Before deploying, you must comprehensively compare models using built-in benchmark metrics. These benchmarks explicitly evaluate quality, safety, cost, and performance metrics like throughput. For instance, evaluating the cost benchmark helps you analyze token consumption efficiency to firmly prevent budget overruns. Generative AI models inherently charge based on token consumption, so selecting a model that perfectly balances cost with your baseline quality threshold is a critical architectural skill. Thorough benchmarking guarantees that you do not carelessly over-provision expensive models for simple, repetitive tasks. In this module, we will deeply explore how to select the right deployment types to maximize your quota, how to aggressively handle strict rate limits for intensive workloads like video generation, and how to optimize your prompts to reduce token usage and lower costs. By carefully analyzing these benchmarks, you make informed decisions about model selection. Evaluating model performance manually and automatically ensures you strike the perfect balance between quality and cost before exposing the endpoint to production traffic. Let us dive in. This conceptual code illustrates how an architect might programmatically pull benchmark data from the Foundry catalog to evaluate cost and throughput efficiencies before committing to a deployment. This flowchart maps the initial planning phase. You select models from the vast catalog, subject them to rigorous benchmark analysis for throughput and cost, and use that data to configure your deployment. When you are ready to deploy a model in Microsoft Foundry, your choice of deployment type directly dictates the operational quota, scaling behavior, and cost structure of your API endpoint. A deployed model transforms from a static asset into a scalable API endpoint, ready to handle your application's remote requests. Microsoft Foundry provides distinct deployment tiers to perfectly match your specific workload requirements. If you are building a production-ready application intended for general use across a large user base, you should absolutely select the global standard deployment type. As highlighted in Microsoft Foundry documentation, the global standard deployment is best for general use while offering the absolutely largest available quota. This maximum quota ensures your application can effortlessly handle massive, concurrent user traffic without hitting aggressive throttling policies or frustrating timeout errors. Conversely, if your team is simply prototyping or running localized internal tests, the developer tier deployment provides a cost-effective environment, albeit with much lower rate limits and quotas. Furthermore, for massive, asynchronous data processing tasks where real-time latency is not a concern, such as nightly document summarization, you can seamlessly utilize data zone batch deployments. Selecting the correct deployment type is the most critical step in managing your workload scalability. Over-provisioning leads to wasted budget, while under-provisioning leads to rate limit errors. You must explicitly define these deployment parameters, such as target capacity, when provisioning the endpoint. Testing these endpoints in the interactive model playground allows you to validate throughput and response latency under simulated conditions. By matching your anticipated user demand to the appropriate deployment type, you guarantee a seamless, highly responsive experience for your end users, while maintaining strict control over your cloud expenditure. This configuration explicitly mandates the global_standard deployment type to secure the largest available quota, setting a high target capacity to prevent scaling bottlenecks in production. This decision tree guides you through selecting the correct deployment tier based on workload demand, ensuring you obtain the necessary quota while effectively managing rate limits and cloud costs. Managing your cost footprint goes hand in hand with maximizing your model's throughput. Throughput is a critical performance benchmark that explicitly indicates the model's ability to process prompts and return comprehensive responses quickly. High throughput is essential for interactive chat applications or voice live agents, where low latency is completely non-negotiable. However, high throughput models often consume tokens rapidly, which can inflate costs. The most accessible way to optimize a model's performance and manage your cost footprint simultaneously is through prompt engineering. Prompt engineering requires no additional back-end infrastructure or custom training data. It is the process of designing and rigorously refining prompts to improve the quality, accuracy, and relevance of responses. By writing highly efficient, concise prompts, you drastically reduce the number of input tokens, which directly lowers your billing costs. A critical component of this token optimization is the system message. A system message firmly defines the assistance role, behavioral boundaries, and exact output formats, such as structured JSON. By explicitly commanding the model to be concise and to output only the absolutely necessary data, you aggressively minimize generated output tokens. Furthermore, using techniques like few-shot learning, providing one or more examples of the desired output, helps the model instantly identify the exact pattern you want, eliminating verbose, hallucinated explanations. You can quickly test these powerful optimizations in the Foundry model playground. You can dynamically adjust parameters like max tokens to enforce strict response length limits, acting as a financial safeguard against runaway token generation. If prompt engineering alone cannot ground the model sufficiently, you can integrate retrieval augmented generation, which supplies precise context, preventing the model from wasting tokens on incorrect guesses. This layered optimization strategy is vital. This code demonstrates token optimization. A strict system message forces a concise JSON output, while the max_tokens parameter guarantees the model cannot generate excessively long, expensive responses. This flow visualizes token optimization. A user prompt is heavily guided by system instructions, utilizing few-shot learning and strict formatting, capped by a max token limit to deliver a cost-optimized response. Certain advanced AI workloads, such as video generation, operate under strict, highly specific rate limits due to their immense computational requirements. Let us explicitly examine how to manage rate limits and scaling when working with asynchronous multimodal models like Sora 2 and Microsoft Foundry. When you deploy a Sora 2 model to generate realistic and imaginative video scenes from text prompts, the generation is an asynchronous process. You submit a job, poll the API for its ongoing status, and download the result when it finally reaches the completed state. Because rendering high-resolution video is incredibly resource-intensive, Microsoft enforces explicit rate limits on these specific endpoints. Currently, you can run up to a maximum of 2 video creation jobs simultaneously. If your client application aggressively attempts to submit a third concurrent job, the API will return a strict rate limit error, and the request will be blocked. To build a resilient enterprise application, your backend code must actively handle these rate limits by implementing robust queuing systems or exponential backoff and retry logic when invoking the Python SDK. Your application must smoothly handle status transitions such as queued, in_progress, completed, or failed. Additionally, you must manage storage quotas efficiently. Completed videos generated by the Sora 2 model are only available for download for exactly 24 hours before job expiration occurs. Your architecture must automatically retrieve and securely store these massive media files into an Azure Blob Storage container before they expire to avoid paying for expensive, redundant regeneration requests. Handling these specific constraints properly ensures that your backend infrastructure remains stable. We highly recommend monitoring the failed status to gracefully alert users without continuously retrying broken prompts, thereby conserving your allowed concurrent job slots. This logic demonstrates polling an asynchronous workload while respecting infrastructure limits. It continuously checks the job status and ensures the asset is downloaded before the strict 24-hour expiration window. This visual outlines asynchronous rate limiting. Jobs are checked against the 2 concurrent job limit. Approved jobs are polled until completion, requiring immediate download before the 24-hour asset expiration policy triggers. Moving from standalone models to autonomous AI agents introduces entirely new challenges in managing workload scaling and costs. AI agents actively utilize built-in and custom tools to perform complex tasks, such as querying databases or executing code. Every single time an agent decides to autonomously invoke a tool, it consumes additional tokens and API calls. To effectively manage the cost footprint of these agentic workloads, you must heavily optimize how they retrieve external information. Traditional language models entirely lack your organization's private information, which naturally leads to expensive hallucinations. To definitively solve this, you use Retrieval Augmented Generation, or RAG, via Microsoft Foundry IQ. Foundry IQ acts as a fully managed knowledge platform that connects your agents to enterprise data sources like Azure AI Search, SharePoint, and Microsoft Fabric OneLake. The cost-saving advantage here is massive. Foundry IQ provides a shared knowledge base. Instead of building isolated, highly redundant retrieval pipelines for dozens of distinct agents, multiple agents can seamlessly query one centralized vector index. This drastically reduces your underlying storage and compute costs. To further optimize agent workloads, you must strictly configure the agent's system instructions to forcibly control its retrieval behavior. You must explicitly command the agent when to use the knowledge base and when to safely rely on its base knowledge, directly preventing unnecessary, expensive search queries. Additionally, when defining custom tools, ensure the data returned to the agent is highly filtered. Flooding the agent's context window with massive, unstructured JSON responses from an API tool will quickly exhaust your token limits and inflate your costs. By diligently monitoring how often your agents invoke these tools, you can refine their instructions. This continuous optimization ensures your enterprise agents deliver factual, grounded responses without incurring unnecessary computational overhead. These strict system instructions act as a cost control mechanism. By forbidding the agent from using tools during casual conversation, you drastically eliminate unnecessary API calls and save significant inference tokens. This diagram illustrates the shared knowledge advantage. Finally, managing quotas, scaling, and costs must be deeply integrated into a broader strategy of responsible AI management. As your AI workloads scale to handle thousands of concurrent users, the potential for generating harmful or out-of-scope content scales proportionally. Microsoft emphasizes a rigorous four-stage process for responsible generative AI: map, measure, mitigate, and manage. To truly manage a responsible generative AI solution, you should aggressively consider a phased delivery plan. A phased delivery plan strictly enables you to gather real-world usage data, identify unexpected rate limit bottlenecks, and collect user feedback before releasing the solution broadly. This highly controlled scaling entirely prevents sudden spikes in traffic that could easily overwhelm your global standard deployment quotas. Furthermore, as you monitor the live system, you must continuously evaluate the model's performance. You can effortlessly use automated evaluation metrics within the Microsoft Foundry SDK to continuously measure dimensions like fluency, relevance, and groundedness. Groundedness specifically ensures the model's output is based strictly on your provided context, which is absolutely critical for validating RAG deployments. From a security and a cost perspective, implementing content safety guardrails is essential. Guardrails expertly help mitigate harmful content generation directly at the safety system level. By aggressively intercepting and blocking toxic prompts before they are fully processed by the large language model, you not only fiercely protect your users, but also save valuable compute tokens that would otherwise be completely wasted generating inappropriate responses. Continuous improvement keeps your generative AI applications perfectly aligned with user needs, while strictly adhering to budget constraints. Always track changes in your version control repository, ensuring every update to your system messages or tool definitions undergoes peer review. Thank you for joining this deep dive. If you found this session valuable, please like, subscribe, and visit quicktechie.com for premium certification prep, including extensive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides. Keep optimizing. Executing automated evaluations programmatically validates that your optimized, scaled deployments continue to perform accurately.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.